But after the break, the Earth's atmosphere. How much longer can it protect us?
$600 million tons of gas surround our planet. Heated during the day, cooled at night. Swept up into storms, hurled around by winds, these gases, our atmosphere, seem far too massive and strong for we humans to change. But while the atmosphere might seem massive, it's in fact thin and fragile, and apparently becoming more so every day. Humans have walked this earth for close to 3 million years. Our industrial world has existed for a mere 200 years. So if you think about that a slightly different way and try and imagine humans being around for only 24 hours, then the industrial age would have started just 5 seconds ago. And we're only now realizing that in those 5 seconds, we've caused major changes to our planet's atmosphere. And ultimately, we'll change its climate. Now, there's been a lot of talk in the world's media about these possible changes, but much of it, let's face it, has been full of hot air. Tonight, in this special report, Beyond 2000 finds out what evidence there really is for what scientists think could turn into the next century's climatic catastrophe. If the Earth was a marble, its atmosphere would be as thin as a layer of condensation on its surface. But thin and fragile though the atmosphere is, it's the only thing which allows life to eke out an existence on what would otherwise be an inhospitable lump of rock, planet Earth. Mars is perhaps what Earth would be like without its atmosphere. Considerably colder than your freezer, it's dry and almost certainly lifeless. While Venus, twice as hot as your oven, could be Earth with too much atmosphere. A boiling soup of gases. Again, unable to support life as we know it. Earth, it seems, is just right. But what makes it so isn't just our distance from the sun, it's the gases inside the Earth's atmosphere. And specifically, this gas, CO2, or carbon dioxide. All animals breathe it out, all plants breathe it in. We produce it whenever we burn anything, and we use it to make soft drinks fizzy. But what makes it important in the atmosphere is that it traps heat, just like the glass in a greenhouse. When light reaches us from the sun, a large part of it travels straight through the 50 kilometers of atmosphere. When it strikes the ground, it radiates back out as heat. But while atmospheric gases like carbon dioxide, water vapor, and methane can let through light, they can't let through heat. With nowhere to go, the heat has nothing to do but warm the planet. On Earth, carbon dioxide accounts for just 0.03% of our atmosphere. And yet, without those tiny amounts of CO2, the temperature around here would be below freezing. Just minute traces of the gas affect the temperature of our whole planet. But it's more than tiny traces of the gas that we've been pumping into the atmosphere. Every kilogram of coal, gas, or oil produces 2 kilograms of carbon dioxide. Each year, we put 5 billion tons of the gas into the atmosphere. But though it's the main culprit, carbon dioxide isn't the only guilty gas. Methane, produced by cows, pigs, and even termites, as well as by the natural rotting of vegetation, is also a greenhouse gas. The more people we have to feed, the more methane we're going to produce. Turning vegetarian won't help either. Nitrous oxide, used heavily in fertilizers for all plant crops, is also guilty. But while the atmosphere may be able to put up with these two chemicals, it may not be able to put up with the amount of carbon dioxide we're producing. The effect, scientists say, will be like enclosing the Earth in a greenhouse.
About 30 years ago, when it was first suggested that man might be changing the carbon dioxide levels in the atmosphere, serious attempts were made to monitor the concentration of carbon dioxide by setting up special observatories around the Earth. And so we now know for certain that that particular gas has increased steadily in the atmosphere.
Cape Grim in Tasmania is one of those observatories. Because the air there is blown over pure Antarctic oceans, the air whistling through the measuring instruments is some of the cleanest in the world. But in just 15 years, the air has changed. CO2 is on the increase. At Mauna Loa, Hawaii's highest peak, and at stations dotted around the globe, the story's the same. But what's to say that this rise in CO2 isn't perfectly natural, just one of nature's whims, and nothing to do with humans? The answer could lie inside 1,000-year-old air, trapped in the Antarctic ice and buried under hundreds of meters of snow. Analysis of the air shows that CO2 levels remained constant for centuries. But in 1810, just 50 years after humans started using coal in industry, the levels started to shoot up. It's not conclusive proof that man's activities have pushed up CO2 levels, but it's pretty convincing. So carbon dioxide is on the increase. But is the temperature? Average temperatures around the world have been rising for the last century. But can scientists be sure that it's because of the greenhouse effect? Until recently, they couldn't. On October the 1st, 1987, a team of Soviet and French scientists published their findings. They had drilled more than a mile through the Antarctic ice to a depth of 2,083 meters. The 160,000-year-old air had been trapped at a time when Neanderthal man roamed the planet. The air was analyzed for carbon dioxide and deuterium, a radioactive element which could give an idea of the Earth's temperature, and the results were impressive. The Earth's temperature rose and fell in perfect tune with variations of carbon dioxide.
The rate of climatic change is unprecedented in human history, and one would expect it to have quite serious consequences.
One can expect more coastal erosion, inundation of coasts.
This area may get drier, and of course that would have serious consequences in terms of food production.
Coming up next, we'll look at those consequences in a weather forecast for the 21st century. Carbon dioxide, the greenhouse gas which threatens to overheat our planet, isn't just produced by humans burning coal and oil. Volcanoes above the ground and sea vents below the sea pump the gas into the atmosphere.
Which should drift across New South Wales later in the week. On the weather chart, this high over here is what is really affecting all the weather that we're
Predicting the
experiencing.
weather on a day-to-day basis is anything but easy. Meteorologists have to think of what the air at a height of up to 10 kilometres or 6 miles is doing at any one moment. And they have to know how that air will affect any other air. But imagine the task of an atmospheric scientist who wants to predict the weather of the 21st century. They have to work out not only what the air will be doing, but what the air itself will be like. Only a computer program several thousand lines long can handle the complex calculations of what CO2 might do to the climate. Different computer programs in different countries come up with different values, but they all point to a rise in temperature.
Now those models broadly predict that in the next 30 to 50 years we will expect the equivalent of having carbon dioxide double and a warming of the planet on average of between about 1.5 and 4.5 degrees.
The North Pole could be the hardest hit, warming by over 4 degrees, with the tropics warming by just 2 degrees. But the warming itself will do little damage. It's the change in rainfall which could hit us hard. Even harder to bear would be the rises in sea level. As the sea warms, it expands, and as it expands, the sea level rises. A 2-degree rise in the Earth's temperature could raise the sea level around the world by over 1 meter. Further temperature rises would eventually melt the Antarctic ice cap. Though this couldn't happen for hundreds of years, if it was to happen, it would raise the sea level by up to 20 meters or 70 feet, wiping out vast areas of the inhabited world. More realistically, scientists are working on the global effects of a rise in temperature of just 2 degrees. Atmospheric scientists admit that the computer models are simplistic, But they've nevertheless come up with a shot in the dark. A weather forecast for the year 2030. The United States faces severe problems. Droughts there will turn the breadbasket of America into a dust bowl, leaving Canada, with a now much warmer climate, to reap the benefits. California, meanwhile, will have the worst of both worlds, floods during the winter and droughts during the summer, forcing cities like San Francisco to ration water. Meanwhile, Florida and other parts of the Gulf of Mexico will be facing the worst floods on record. Moving across to Europe, Mediterranean countries will be facing droughts, while Northern Europe faces floods. Holland will remain protected from the rising sea behind the country's barrages, but London's Thames barrage may not be able to cope with the rising sea levels, and the city can expect severe floods. Up in the Soviet Union, the permafrost will start to melt, releasing yet more carbon dioxide and causing cities to sink into swamps. Parts of southern Asia will suffer catastrophes, with low-lying Bangladesh having nowhere to escape to as the sea levels continue to rise. Australia faces an expensive shake-up, but should come out of it relatively well. The north and northeastern parts of Australia will get more summer rain, and so will the capital cities of Sydney, Melbourne and Hobart, all three of which are likely to face increased flooding. Adelaide will suffer water shortages, but things will be even worse for Perth and the southwest of the continent. These already dry areas could suffer such severe droughts that populations will be forced to leave the area. In terms of sea level rise, the Great Barrier Reef will flourish, but waterside properties, particularly along the Gold Coast, will face inundation from the sea, especially when the seas are whipped up by tropical cyclones. Further south, both Sydney and Melbourne will eventually have to consider building barrages across their harbours. So the overall outlook for Australia: more rainfall and agriculture in the north, but floods and droughts in the south.
I think one of the big advantages for Australia is the extent of the country and the fact that the country already expands over a wide range of climatic zones. And if we are to have a general shift in climatic regions, then one can conceive over a period of time a population centres actually moving.
For the rest of the world, the picture is less rosy. Carbon dioxide is inevitably linked to our standard of living. The energy we consume, the food we eat, the products we make. Virtually everything we do puts CO2 into the atmosphere. Solving the problem will be anything but easy.
We have 25, 30 years to clean up our act. There's no simple answer. We have to confront this on with many different approaches. Clearly, conservation of energy. If we try to use less energy per capita, that would be important. Clearly, if we had less people, it would help, and therefore a global attitude to the restriction of population growth is very important in this issue. It really is a problem of numbers. How many people there are that are burning this carbon? The system can't handle too many people doing it.
Technology might one day come up with an answer. Coral reefs, for instance, mop up carbon dioxide by turning the gas into limestone. But we'd need artificial reefs covering whole oceans to cope with the amount of CO2 we produce. Any technology which can solve global problems without causing problems of its own won't come cheaply, and it'll be our children who'll be paying.
All we can hope to do now is to try to prevent the change from worsening so severely that our whole civilization and way of life might one day be put at risk. The solutions won't come from our world leaders. They'll come from people like you and me. If we can be aware of the problem and be prepared to pay for the solutions, then we'll solve it. If we're not prepared to take that responsibility, then it'll be our children and their children who'll have to suffer.
Our look at Earth's atmosphere and the damage we're doing to it continues on the next edition of Beyond 2000.